站在前面啊，我应该站在前面。好，我站在这边开始好了。好。我看着可以吗 ？Okay, welcome to attend this session. This session is about delivery without contact. Okay, so good morning, good afternoon, good evening, wherever you are. Well, we have now it's about 7 p.m. In Taiwan, but welcome. So. So each group has about 8 minutes for their presentation, and finally we will have 50 minutes for Q&A. Next slide. So my name is Liter Yao. I'm the director of CityScienceLab at Taipei Tech. I'm also the professor in electrical engineering department. Next. We will have 3 groups, okay, and each group will have one mentor. So the first mentor is Professor Fang. He's the professor in Department of Industrial.
没声音。
Professor Zheng, he is the professor in Mechanical Engineering Department. Next. So if you have any questions or any comments, please, this is the QR code for our Slido. So please, if you are interested in this, please take a photo for this. So in the last 15 minutes, we will have Q&A. So please just type in any question you.
Professor Yao, I think we might be having some issues with your audio. Would you mind? I'm not sure which conference room the microphone is coming from.
So,
so Christina, can you hear me?
Yes.
Do you want me to start over again?
So, how about we share the Taipei Tech conference list, the Zoom icon. Oh.
I think just now we could hear Professor Yao again. It was cutting in and out a little.
Can you hear me now?
Yeah.
Yes.
Okay. Do you want me to start over again?
Yes, I think so.
Okay, let's start over again. Oh, really? Not like it's.
MIT 那边控制的。
你要跟他沟通啊，沟通说。
所以现在是他那边没有，他是好，
说这应该就没有问题。
Okay. I'm sorry. So I'm sorry, due to some technical problems, so we have to start over again. Sorry. Well, that's good morning, good afternoon, good evening, wherever you are. The theme for today is delivery without contact. Okay. Next. So today's agenda is about this. So I will spend 20 minutes introducing the theme of this session, and then we will break up into 3 groups. Each group will discuss the related topic in this session. So it will take us 20 minutes. Okay, and then after this, we will ask. We hope that you could select one representative from every group to present your idea, your conclusion for your discussion, and then it will take us 25 minutes. And then in the last 15 minutes, we will have Q&A. So my name is Liter Yao. I'm the director of CityScienceLab at Taipei Tech. I'm the professor in electrical engineering department in this school. Next. Because we are going to present our discussion into three groups, so every group will have a mentor. The first mentor is Professor Fang. He is the professor in electrical engineering. He is the professor in industrial design department. The second mentor is Professor Lin. He is the professor in Graduate Institute of Automation Technology. And the third mentor is Professor Zhang. He is the professor of mechanical engineering department. Next. So in the last 15 minutes, we will have some Q&A. If you have any comments, any questions, you're welcome to type in your questions or your comments. So this is a QR code for the Slido. Okay, so please take a photo for this QR code, and so that you could type in whatever you want. Next. So again, the theme for this session is delivery without contact. Next. Well, without what contact? Let's define our question. The clear definition is delivery without person-to-person contact. Well, if we are going to do our delivery without person-to-person contact, then how can I deliver whatever I want to deliver to the receiver? Then in this session, you will see we will make a self-driving vehicle to deliver the object for us. So, well, there are 3 scenarios. The first scenario is that the delivery is called by the sender. Okay, and that could be divided into 2 parts. One part is that the sender loads the object he or she want to send into the robot or self-driving vehicle, and this self-driving vehicle will take this object automatically to the receiver. Okay, so this is the first part. The second part is this. Well, the sender does not need to personally load the object into the robot himself or herself. The sender can call the third party to deliver the object he wants to send. So the third party, by the request from the sender, will deliver the object to the receiver. Okay, you can imagine this is like Uber Eats. Okay, so you can deliver whatever you want to send to your friends, so that you can just ask the Uber Eats to send the food to your friends. So this is the second part of the delivery called by the sender. Okay, next. So the second scenario is this: delivery is called by the receiver. There is no sender. Okay, so the receiver is also the caller. Make the call. So the third party will deliver the object back to the caller. So the caller is also the receiver. So this is the second scenario. Next. The third scenario is this. Imagine this. If we have intelligent self-driving vehicle, you can imagine that we will see vending machine moving around. Okay, so we will see vending machine moving around the campus, moving on the streets, in the park, in the train station, subway station. So the delivery is called by nobody. So if the pedestrian happen to see the moving vending machine and he or she like the object inside the vending machine, he or she can stop the moving vending machine and then pay and then take whatever he or she like, take the object from the moving vending machine. So the third scenario is delivery is caused by nobody. Just they just bump into the moving vending machine. If they want, they just stop it and take out the object they want. So next, we want to ask ourselves, why do we need to do the delivery without contact? What are the advantages doing delivery without contact? Well, for my opinion, there are several reasons. One of the reasons is for sanitation. Of course, you understand this. We now have COVID-19. We have this pandemic. So if we want to deliver one object, if we want to send one object to the receiver, we don't want to deliver this object in person. We want self-driving vehicle to do the delivery for us for the purpose of sanitation. The second purpose is probably because of the privacy. Well, some of the receiver, they don't want to be bothered by the person who delivered the object, or the person the receiver does not want anyone know what object he or she is receiving. So because of the privacy, we want to do delivery without contact. And the third one, you understand very easily. It is because of the convenience. It's very convenient. You can ask for delivery anytime you want. Okay, you can ask the delivery even during the midnight. Okay, and the fourth reason is efficiency. It is very efficient because it's convenient. You can keep your privacy. It's good for sanitation. Of course, it is efficient, and the fifth one is the cost. Sooner or later, we will see that delivery by person is very costly. Okay, the labor cost is very costly. So if we can ask machine to do the delivery for us, then it can save some labor cost. The next reason is we could promote ourselves. Imagine this, as I have mentioned in the previous slide. In the future, actually, it's in the near future. You'll see many moving vending machine moving all around. Okay, you can even imagine that you can see a vending machine selling makeup for girls. Okay, so when you just step out of the subway station, if you want to do some make up, and you can just buy it from the moving vending machine. So by doing this, you could promote your sales, okay? And the last one is that, well, if we have so many moving vending machine moving around in the park, in the subway station, you can from the stockpile in the vending machine, you will understand what kind of objects the customer or the pedestrian like most. Okay, so and because this moving vending machine can move around, and it is also a very good marketing machine. Okay, so you could promote your new products. Okay, those are the reasons. So well, we have been working with Media Lab in the past 3 years. We are cooperating with the PEV. And so we actually have one PEV. We built one PEV in Taipei Tech. So in the next video, I want you to see the PEV moving in our campus. Okay, let's see some video. This is about 30 seconds. Okay, apparently you can see that PEV is good for the last mile of transportation. PEV is not delivering goods; it's delivering human being. Okay, this is actually a tricycle. So this is a self-driving tricycle. So we have been sending our students to Media Lab, and those excellent students come back to Taipei Tech, then they help us to rebuild this PEV. Okay. Okay, next. Okay, so well, because of the Professor Larson's brilliant idea, PEV could serve the last mile transportation. PEV is good for the last mile transportation from the station to the building we want to go. Okay, so this PEV could serve the last mile transportation, and the motivation for our gadget, which I'm going to introduce to you, is how about not the last mile, the last 20 meters, okay? So we are going to show you a self-driving vehicle moving around inside or outside of the building. Okay, next. So we are going to show you our gadget. It is called Campus Rover. You can imagine this is a self-driving vehicle which can deliver, of course. Well, we see our students just play around this. Just show you that this vehicle is able to carry about 70 kilograms. Okay, so last one. So this is our old version. So we have two old version self-driving vehicle. Next one, and so this is our new version. Well, actually, we just put the outfits. Put outfit on our old gadgets. So this is our new outlook for this Campus Rover. Thanks for Professor Fan. He and his student do this design for us. Thank you. So what should the function of delivery vehicle have? Okay. So what are those technology we should have? The first technology we should have is the outdoor self-driving technology, of course. And if the self-driving vehicle is moving outside, it can receive the GPS signal, so it's easy to locate itself. But if the self-driving vehicle is moving inside the building, this vehicle cannot receive the GPS signal. So we need to have indoor self-driving technology, which is basically artificial intelligence. And the third technology we should have is environment recognition technology, because even we could have some electronic map for the self-driving vehicle moving inside the building. We still need to have good artificial intelligence technology to let this vehicle recognize the environments. And the next is that, of course, it also need to have obstacle and moving object avoidance technology in order not to bump into any objects. Next. And then we have buildings. So we want this vehicle could push the button to get into whatever to operate the elevator itself. So we need to have elevator operation technology for this self-driving vehicle also. And of course, it is safety is is also the primary concern we need to have. So this vehicle also need to know the safety technology. And of course, also this self-driving vehicle, we also design human interaction technology so that this vehicle could interact with human being. Next, and we want to deliver the right person. If the person is not right, we don't want any stranger to open the box to take the object. So the authentication technology is also important for this self-driving vehicle. And the last one is lighting and audio signaling technology, so that the pedestrians will know the moving self-driving vehicle. So in Taipei Tech, we have some experiments for our campus rover. So I want you to take a look at our experiments. Next. Okay, as I mentioned that you see, this vehicle is able to operate the elevator, so it can push the button to go up or go down. We designed the robot arm by ourselves. So it recognized the button and then push the button itself. After pushing the button, this vehicle will get into the elevator without bumping into the wall. You see?
我要进电梯，请让个位给我。
Little girls walks to remind anyone inside the elevator. This robot is getting to the elevator, and after getting to the elevator, this also we also need to, the robot is able to recognize the button, whatever floor it is going to push the button. And then when the elevator opens, it will be able to go out by itself. Okay, so and after going out of the elevator, this robot can go into the. We now are able to do door-to-door delivery service, because this robot is able to recognize also the environment and associated with the electronic map. And of course, okay, so
不好意思，借过一下。
yes, we also have some obstacle avoidance technology. This is our lab, and of course, if it is able to sell inside the building, it can also sell like PEV outside of the building. So this PV now is able to receive the GPS signal and do the environment recognition also. Okay, so and then we also now we are going to put beautiful outfits to our self-driving vehicle. Okay, so this is our new campus Rover. Okay, so this is about the brief introduction of today's the theme for this session. So next, oh, I'm sorry. So next one, I'm also going to show you, we also designed a simple type self-driving vehicle to deliver food in a campus cafe. Well, within 1 or 2 months, we are going to receive the order for the student living in the dormitory. They can make their order online, and then this vehicle could deliver the food to their door. Okay, so this is what we are going to do. So this is another simple type food delivery robot. I'm going to show you the idea. We do our experiment in our campus cafe.
I have a wonderful electronic
This one
invention I want you to see.
is not that complicated.
It looks something like this.
So the person could put the food inside this robot, and the robot close the door and deliver the food to the guest. And go back. Okay. And of course, it can also collect the tray and collect the garbage. So when the guest finish the food, and he can call for the robot to deliver the tray back to the store. Okay, so this is the experiment for food delivery. So well, we have shown you two scenarios. Now I want you to have brainstorming. What other scenario can delivery without contact be applied? So we will we will have, let's see, we will have 20 minutes breakout discussion. So we will break all the audience into 3 groups. I want you to do your brainstorming. What other scenario can we do? Can we do? So the first group will focus on medical service without contact. The second group will focus on transportation without contact. The third group will focus on entertainment without contact. So please just choose any group you like, and after 20 minutes, we'll see what are your brilliant ideas. Thank you.
Okay, thank you, Professor Yao. I'm gonna send everybody out into breakout groups now, and you guys will likely see a countdown for the 20 minutes, and then we'll see you back here.
Okay, thank
so
you.
Here we go, everyone.
All right. 可以把我
I'm going to share my screen now so that I could play the video.
Thank you. Well, it's time flies. So I'm sorry. I know every group has the very interesting discussions. So now we want all those three groups to give us some to present their summing up ideas. So now the first group. So let's see what first group what ideas can first group come up with. Okay, so Professor Fan, you are the first group, right?
Yes.
Oh, okay, Professor Lin, you are the first one. Professor Lin. So the first group is transportation without contact, right?
Okay. Thanks, Professor Yao. So we'll send Josh just make some conclusion for this.
Okay, hello guys. So we kind of talk about like how to deliver food like with like autopilot vehicle.
Okay, wait a second. Yeah, go ahead.
Okay, so we kind of talk about how to deliver food or like objects with autopilot vehicle, and also we came out with some idea about when people usually go to some crowded places, for instance, night market. We can like make like a machine that can move around by itself, so people can go pick up, which can reduce the chance of exposure to the virus. And also we also talk about like underground transportation. So because right now in California, Elon Musk is having a huge plan, like they gonna establish the underground tunnel for car to use it. So I think it will be like a good opportunity for each individual to like separate and achieve the goal of delivery object and receiving object. And also, we also talk about like during this pandemic time, the relationship. How do maybe we can create robots? But even though I think it might be a little weird to like date a machine or like date a machine with your girlfriend's image on there. But yeah, I think it still will be like a new chance to kind of relieve people's stress during the quarantine time. Yeah, and that's what we discuss about. Thank you.
Yeah, that's it. Should I make some comments or that's it?
Yeah, please, Professor Lin.
Oh, yes, I think that that's about it. So I think transportation without contact is super important, especially the time of the coronavirus. So people feel scared about how the contact with people. So we are talking about a lot of technologies and ideas about how to deliver food, how to deliver objects, especially how to improve the social interaction with the people. I think still we have a long way to go, but I think we should just interact. We should cooperate with MIT CityScienceLab with more ideas. I think that's a very good topic, good track to go. I think that's our conclusions.
Okay, thank you. So we'll go to the second group. Professor Zheng, you are the next. Professor Zheng.
I think you might be muted.
Are we in now?
Professor Zheng, can you hear us?
We can hear you now.
Okay. Professor Zheng,
so Willy,
you are the
please.
second group.
We will have
Okay.
Willy Wu to present our discussion first.
Okay, so entertainment without contact. there are different parts in entertainment, and in this under this epidemic situation, we first would like to talk about the relationship with each other, and we discussed that we can have dating robots that can mimic the human touch and have used VR to have karaoke with friends and or even watch sport games. And then we have things about shopping that, oh, and I forgot to mention that we talk about that we can share food with people by getting the same food. And with shopping, we can shop online and use the AR technology to see the item first and digitalizing the physical items. And when we really go to stores, we can have auto checkout machine to have less contact and a digital cash flow. And also we can have robotic bands to celebrate things, to have music.
Okay. Anything else?
It seems,
Okay, so
yeah, our discussion here has talked about using the digital technologies or robot technologies to help people interact with other peoples. But I think also in the future, if we can have some better medical protection technologies, maybe we can have people get closer around, but not really have contact, so that we can enjoy like a concert or sports event together while keep a short distance from other people. That's what we expect in the future. That's all we have. Back to
okay,
you,
thank you.
Professor Yao. Yes.
Thank you. Okay, so our last group is from Professor Fan. So
okay, in this group is a method without context. So we will let Ethan to share our result to everyone.
Okay, so while he's pulling it up, we have like about 8 ideas that it should be coming up now. The first one is about covering for medical staffs when we are short-staffed, so robots can help cover for them. Another one is robots that can help deliver blood or medical equipment for both hospitals and communities. Another one is using 5G network to connect with other medical staffs around the world so they can help solve problems together. Another one will be maybe scan barcodes to help determine if the medicine is right for you or if it's expired or anything. Or you can even have robots doing health code because doctors and nurses are really important right now and they're fighting on the front line. So maybe they can substitute that and then they can come to your house to check on you if you're actually sick or not, so you don't have to go to the hospital. And then we also have idea of building sensors around communities, both public and private, so in business as well, so they can check on you to monitor if you're sick or not. We can also use robots as EMT, so they can help first responders like with ease. And then the last one will be like self-driving hospital bed that help doctors and nurses monitor the patients. And that's pretty much it we have for medical service without contact.
okay, thank you. So Professor Fan, do you want to add anything?
I think everyone shared very interesting ideas, so it's a good time to get together. Yeah.
Okay, so well now, as we can see that every group has presented many brilliant ideas. So well, I really enjoy your brilliant ideas. So our next schedule is Q&A. So anyone, including the audience without microphone, if you have anything want to ask or want to comment, please get into Slido to type in your question or your comments. Again, you can see the QR code is on the screen now. So please get into this Slido and type in your question and comment. You can say whatever you want. So because we save a little bit time, so we might be able to have 50 minutes sharp to for this Q&A session.
Professor Yao,
yeah.
While we wait for the Slido questions, there's actually a couple of questions on the chat if you would like to go through those.
Okay.
You want us to see to watch the video? To watch your camera? Oh.
No.
Here?
There's a couple of questions in the chat. Oh, well, we have a question in Slido, so you can just go ahead.
Well, go ahead. What is your question? Yeah, thank you. Please.
So in the chat from Alaudin, we have, how can the vehicle recognize places inside the buildings? Do we need sensors, beacons, etc., to be installed?
I beg your pardon. You want to add, what is your question again? How can
one of the questions in the chat from the Zoom call is, how can the vehicle recognize places inside buildings?
My building.
Oh, you mean find the building? Okay. See, well, first, in order for the vehicle drive among buildings, and after getting to a building, this vehicle also need to take the elevator to the floor you want to go. So the vehicle actually has a electronic map. Okay. So how do we build this electronic map? We need to scan. Well, actually, we need to control the robot or push the robot around the building so that there is a LiDAR on top of the robot. So the LiDAR is able to scan the building, scan the environment, and then after scanning all the routes, this robot will go. Okay, so all the routes, the robot will go. Then the robot will be able to build a so-called electronic map. So after building this electronic map, then this robot is able to know where it is. But the electronic map is probably not accurate enough. So we also need to add some artificial intelligence so that this robot can also open the camera to recognize the environment. So, integrate with the electronic map and the environment, and also recognize the environment, then this robot is able to go wherever it wants. This is how we sell the robot to the destination.
Perfect.
Do I
Thank you.
answer your question?
Yes, I think that answers the question.
Yeah, thank you. So we have several questions now. How can we prevent the contact between people and the vehicle? For the vehicle, will eventually contact another people. That is a very good question. So yeah, we actually want to prevent people from touching the other people. So we create these robots, but it is unavoidable. Either sender or receiver might touch the robot. That is exactly true. So so far we don't know what to do. But one thing we can make sure is that because robot is not like human being. So after going several rounds of the trip, we can spray all those medicine so that we can thoroughly kill the virus on or inside the robot. This is what we can do. But it is not possible you put spray a lot of medicine onto a human being. But we could do that to the robot. So this is by doing this, we might be able to kind of reduce the risk risk of conveying virus from people to people. Okay. So the second question is that how can we? Oh, okay. So have we ever considered the issue about cybersecurity? Yes. Yeah, we have to do that, but we so far we haven't go so far yet. Okay. And then the third question is that is the
robot can deliver a lot of stuff.
Robot can deliver lots of stuff, but also virus. How can we avoid this? Yeah, this is this is as I have told you. This, do you recycle code from some robot to others? What do you mean code from robot? How are you? What do you mean by recycle code? Recycle code? What is that? One of the audience asked me, how can we recycle the code? I'm not quite sure what that is, but probably it means that can we kind of copy the code, the computer program to the other robot? That's very easy for us to do. This is what we are doing now. So if maybe encounter some area like of a wireless network, so how to solve the problem in case the robot missed the path or specific way? Well, okay, so actually, as I have mentioned, we actually has some electronic map inside the robot. So the robot does not need to count on the remote control from the control center through wireless network. So actually, even though we don't have wireless network in some area, the robot is still able to sail to the destination. Robots can deliver. Oh, 我要看哪一个？
它会最多人排，它会跳上去。
How can we prevent the contact between people and vehicles? For the people will eventually contact another people. Yeah. Okay. Second question: how recycle code? Can you redefine recycle code? I don't quite understand what that is. How should we adjust our mindset to this special scenario for people that doesn't have much familiarity with machine? How should we assist them physically? Yeah, that is a good question. So if we design our robot right, actually we should have user-friendly interface so that people does not need to be familiar with how to operate the machine, and the machine can still do the service for the people. So yeah, this is our goal. We should have eventually we should have a user-friendly interface. Is it possible to design a robot to do surgery if, oh, 掉掉了。
对，它是最下面。
Is it possible to for the future? Which question should I ask? Should I look at? For the future, is it possible to function the device in the whole city like automatic Uber Eats or even worldwide? Yeah, this is a good question. I can guarantee you, because I have seen some reports. I believe in the next decade, 1 or 2 decades, we will see many self-driving vehicles, of course, on the road, okay? We could also see the self-driving vehicle delivering goods, okay, for us. So we we can definitely see 10 times of the scale like Uber Eats. So no question about that, and worldwide. So is it possible to design a robot to do surgery if some places lack of doctors? Yeah, yeah, this is, actually it is, we now have the remote control robot. It is called Da Vinci, okay? So this robot actually costs at least 30 million per machine. This machine is able to do surgery, and we have seen so many cases that the doctor is able to remotely control the Da Vinci to do surgery. And so we do have that kind of technology and real cases right now. Okay. How can we prevent the contact between people and vehicle? I've answered this question before. Okay, that's the robot is damaged. If the robot is damaged on the street and the goods can't be delivered correctly, how do we ensure that it is available? And how about the question of responsibility? Yeah, if the robot is malfunction on the road at this time, we need a wireless network. So if the robot malfunction on the road, then the robot will send the signal back to the control center through wireless network, so that the control center will know this situation, and then they will either send another robot or call the receiver and do whatever compensation they have to do. So this is how a wireless network function, right? At that for that cases. Huh? How can already prevent most of the situation that happen of self-driving car in the traffic? How can we avoid self-driving delivery car from cyber attacks? Well, actually in the video you have seen today, robot technically is not controlled through wireless network. So if we don't use wireless network very often or not at all, then we don't have to worry about cyber attacks. So it's not like one thing is that self-driving vehicle for delivery, we try to reduce the distance. It's not like self-driving vehicle like Tesla, okay? For Tesla, it need to have wireless network because they have to receive the map from time to time. But for this indoor use self-driving vehicle, we want this self-driving vehicle run inside the building most of the time. So we technically we don't need to have take the Google Map from time to time through wireless network. Then we don't have to worry about the cyber attack. How to avoid people to take the carrying on robot when it. Okay. To avoid people to take the carrying, what does that mean on the robot?
So when the robot is running, so maybe some bad people, small groups of bad people take the things.
Story.
Oh, okay. Yeah. Well, see, we within several months, what we are going to do is this: we are going to build 2 self-driving vehicles to deliver to deliver documents or important objects from department to administration administration center in Taipei Tech. So how can we avoid people to take the objects inside the self-driving vehicle? The way we do is this. Say, for example, I'm the professor in electrical engineering department. I'm going to send an important document to foreign student office. So I'm going to send a QR code to the receiver, so that when I call the robot to my lab, and then I put the document inside this vehicle and close the box, so the robot will move to the international student office. Whoever receive my sent QR code, he or she is the only person who can open the box. Okay, so when the robot arrive at the international student office, then the person will show the QR code, so that the box containing the document will automatically open. On the way to the international student office, no one is able to open that box, because that box is locked. This is how we are going to design. Okay, actually, this is how we have designed. Okay, maintenance of the robot. Will the price of the maintenance be affordable for everyone with different economic classes? Yeah, of course. If we have mass production of this kind of robot, then we can reduce the price of the elements and devices on the robot. Then we could reduce the price of maintenance when we do mass production. How can the self-driving machine work in adverse weather conditions, because the visuality is poor? Yeah, that is a good question. We haven't solved that problem, but yeah, good question, because when it rains hard, the camera will be covered by water, or the lidar will be affected by a lot of water. Then the salary will be not accurate enough, so the robot is not able to localize itself. This is a good question. So far, I think that the robot for indoor, the robot to do the delivery, I think it will be better. It will be better if we use that kind of self-driving vehicle inside the building. Okay, inside or outside of the building, and the building, the distance between buildings is not too far. Then we could avoid that kind of bad weather. Okay. How can we avoid the viruses and bacteria from doctors when they are taking things inside the robot? That is good questions, but I believe that the doctor will wear gloves, so we don't have to worry about that. Yeah, yeah. Oh, by the way, so we don't really have to worry about that. But I just want to give you another example. We are going to cooperate with a hospital, a large hospital in Taipei City. So we are going to build a robot for that hospital, so that this robot will deliver medicine for nurses, because every morning the pharmacy in the hospital has to deliver a lot of medicine to the patients living in the hospitals. So it takes a lot of labor cost. So we are going to build that kind of robot, so that this robot is able to deliver medicine for the hospital. This is our first step. And our next step is that when I attend some groups, I know through their discussion, they propose that we could also use self-driving robot to move patients inside the hospital. This is our second step, actually. So we will kind of make the robot like a transformer. It can be transformed into some kind of carrying tool, so that this robot is able to carry patients or even carrying heavy goods and move inside the hospital. This is our second step, actually.
All right, due to the time, so we're going to have one last question.
Okay, so have I answered every question now?
One last question.
Okay, so which one?
Right here. Last one.
Can we also apply the concept of delivery without contact to air and sea freight? Yeah, of course. Amazon has done this before. We could use a flying drone to deliver goods from the warehouse to the caller. So of course we can do that through air or through sea. Through sea, I'm not quite sure. I know there is some self-driving, self-sailing boat developed right now. Actually, my lab is building a robotic fish. If maybe next year I'll show you my robotic fish. It is very interesting. Yeah. Okay, so I do my best to answer every question. I'm sorry, some of the question is not clear, so I don't know how to answer. But yeah, so I hope that I do answer most of the questions. And again, with my staff, I would like to thank all of our participants from every university all over the world. Thank you for your participation. We have a wonderful 1.5 hours, and I hope we can see you here in Taipei Tech next year, face to face.